Mental math and estimation is what we'll cover at the beginning of chapter 4. To start, we look at these problems here. I want you just thinking about how you may solve these using some thinking strategies, right? And we're continuing on where we left off in the previous chapter, where we talk about these types of ways to add, multiply, subtract, and divide, and giving students opportunities to think versus just using some algorithm. And so I'll give you, you can pause and look at some of those and think about it, but we'll go ahead and look at the examples below. And so the solutions are here, so you could always look at that, but let's talk through it. And so before looking at what comes to mind for me on these first one is that 15 and 25 go together pretty well. They're what we were going to call compatible numbers, right? Something I can easily calculate in my head. And so that would allow me then to get to the answer of 67 here. This one looks a little trickier, saying, man, I can't do 21 and times 17 and 13 times 21. But if you notice the 21 is in both of those, you end up being able to use distributive property, right? You can pull out the 21 and then or factor out the 21, and then you're left with that right there, and you can get the answer mentally. Here's another one thinking, man, 56 times 25, that's way too big. What we would use here, though, is commutativity and associativity, meaning that I could move these around. And then you end up with doing 8 times 25 first, and then getting, that's an easier one to get. 8 times 25 is 200. Another way to think about 8 times 25, if you would be 4 times 2 times 25, and then that would be another way to think about it, to make that. If you want to look at another level of compatible numbers, just thinking about it, we could have done 7 times 4 times 2 times 25, and you should be able to mentally kind of carry that around, and there's your 50, and then 50 times 4 is 200. Or again, you could have done 2 times 4 times 25. This one here, I'm going to give, we're close to 100, so I'm going to give this 100, 2, and then you'd subtract 2 there, and so you'd end up with your 157. You can see associativity there. On this one here, I guess we could do a similar thing. You can give this 3, and this becomes 26. 90 plus 26, that could be easier for you. This one, you see, we're looking more of looking at the from left to right approach. 80 plus 20, and then 7 plus 9. You can see that, so that's another way. This one, the division one's always an interesting one for students. You look at 168 divided by 3, and so notice that was broken up. I'm going to write as a fraction so you can see this better, but 168 divided by 3 is the same thing as 150 plus 18 divided by 3. And then what we remember from fractions, that's the same as 150 divided by 3 plus 18 divided by 3, and that's where you get your 50 plus 6. So that's another way to think about that right there. And so that's example 4.1. As we move on, again, I want to introduce this idea of compatible numbers. You want to use numbers that you can easily add, subtract, multiply, and divide. Before we move on to some more examples of this here, this is an interesting discussion here. 15 minus 8. A student said, I'm going to do 8 minus 5, and 10 minus 3 is 7. 15 minus 8 is 7, and then now figure out, would this always work? And so, for example, if we did 14 minus 6, we already know that is 8, but using the technique here, it looks like the student did 6 minus 4 equals 2. So you get that, and then 8 minus 5 is 3 here, and then 10 minus 3, where did we get the 10? Well, it took this here, so then they're going to do 10 minus 2 is 8. So that method looks like it works. The question, does it always work? Something to think about with that. Now, the reason that kind of works is what the student's really doing without writing it down. Why it works is the student's really doing 5 minus 8. Instead of writing 3, they reverse it, but I would say you can do 5 minus 8. If you know your negative number, it's negative 3. And then what you're left over is, then you're left over with, so this really what you're doing is negative 3. And then you're going to have 10 minus 10 minus 3 is 7. And so then when you do the 10 minus 3, you end up with 7, which then works there. But again, that's what the student's really doing. They just didn't write it out. They're using negative numbers without writing that out.